This is the limit when x approaches infinity. Haha. Here we go. Here we go.
Yeah.
Here we go.
Infinity.
No, that's not the limit.
Ah.
This is the limit when x approaches infinity.
Yeah. Limits. Yeah. Go to infinity.
All the way.
The limit of x minus 5 over x plus 3 as x approaches 3 from the negative side.
You're not even going to straight line anymore.
A function can be continuous only if the function value is equal to the limit, the function is defined, the limit is defined, and if there's no hole, if you know what I mean. Wink, wink.
Begin.
Sanjay, I can't show my affection to you. There's a hole. We can't be continuous. No. Sanjay, our destiny has been continued. Man, I love you. Yeah, oh shit.
Daniel saw the two-sided limit. Give it to Sanjay.
Whoa. This is baby food.
Sanjay, what is your answer?
Like it's wrong.
Ah! Aaron, you got a 93% on the final. Help me.
Okay.
Just like,
Alright, son.
Dude, I still don't get it.
Stupid. I'm out.
Robert,
I got
help me.
you, I got you.
Thank you, man. Thanks.
Go.
Oh, so you count that right there?
You don't cancel out of math?
Evil. Alright, so how can I explain this?
Guess I need to forget that with me.
Daniel, explain this to me, please.
hey, I got you, Sanjay. Alright, let me see this paper. Alright, as you can see, first you have to factor out the top. So you must factor x squared minus 4x plus 4, and then you get x minus 2 and x minus 2 over x minus 2. As you can see here, they divide out to 1. So therefore, you must plug in 2, and then you get 2 minus 2, and the limit is 0.
Oh, alright, I get it.
Hey Ron, you got a 93% on the final. Could you please explain the unit circle to us?
Okay. First you do is draw a circle. That a circle, right?
Yeah.
Oh, the y-axis.
That's like a butt cheek, dude.
It doesn't have to be a perfect circle.
Okay, Ron. I must listen to you.
That is not a unit circle.
Alright.
Radius of 1, remember?
Yeah. This is 1. This is negative 1. Right. This right here is pi over 6. Or basically freaking like 30 degrees. This is 45. And this is 60. Oh wait, like alright, like the points are radical 3 over 2, 1/2. Like the points here are this and this. And the points here are this.
And those will always be the coordinates. It just depends on the negative side or positive side depending on their quadrant.
And cosine, what does cosine represent? What about sine, Aaron?
Alright, cosine is like basically like the x. So it means this is cosine, this is your cosine, and this is your cosine.
So it's pretty much your
Oh.
horizontal line.
That
Yeah,
makes a
freaking
lot of
try hard.
sense. That makes a lot of sense now.
Oh, does that mean that the y will equal sine?
No. I mean yes.
Ah,
Yes, yes,
yeah.
yes. Sine is basically the
Sine is-
vertical ones.
Freaking try hard.
Sorry. I'm trying to be like you.
Aaron, you're my inspiration. Teach me more.
You're funny, man. And then this is 90, so it's 0, 1. Because, come on now, it's a straight line. If you can't get this right, then I don't know.
Sanjay, did you know that was a straight line?
Just leave. Please, just leave. Thank you. Thank you.
Sanjay, come learn, man.
Leave!
It's time to complete like this magical circle. Magical circle.
The unit circle.
Nope, it's a magical circle.
Why? Whatever you say, Ron.
Cause look at it. It's magic, man. Another 3 annoying lines, right?
Yes, sir.
Right. This is what? 120, right?
Yes, the second quadrant.
It's 135.
180.
That's 150, man. Right?
Yes.
Oh, I was talking about this one, dude. 180 here.
Relax. Calm down. Relax.
Alright.
Right.
Sorry, Ron.
¿A dónde está la mesa ya para que no se estén ahí agachados? Sordo.
Más, espérate. You know what? Screw this. I'm done.
You don't need this, man. Who said this? Who said this? It's done. Bye.
I'm out.
No, hey, Ron.
Oh wait, hey, there's always Google.
Alright, let's go.
Hey guys, I found a picture on Google. Guys, Google picture.
Here we do it.
No.
Thank you, Roberto. You're a good backup. Just don't slime me this time.
Alright.
I told you Google has everything.
Sanjay, that's not the unit circle.
Told you not to slime me.
I'm sorry, baby. Sanjay, this is the unit circle. Like, remember Aaron when I explained to you earlier the 3 lines and the 3 coordinates? Well, they repeat, but the positive and negative side matters depending on their quadrant. Now, this side we see 3 lines again, right? And then we see the 3 coordinates again. Well, this one's in quadrant 2, so that's why x, being the horizontal line, is going to be negative because on the negative quadrant. And it repeats again, as you can see, right?
Look at that. Try hard.
Oh my god, Aaron, calm down. I didn't get a 92 on my final, okay? Alright, and then continuing, 3 lines again, you see all over. So those pretty much represent the cosine and sine graphs. And the coordinates are going to be there again. Now the angles, if you go from 90 to 120, that's increasing for 30. Same for right here, 150 to 180 is 30, 180 to 210 is 30, 240 to 270 is 30, 270 300 is 30, 330 to 0, which is 360, it's going to be 30, right? Now the middle ones, these two, increase by 15, so 120 plus 15 is 135. Do you get it?
Mm-hmm.
And the north, east, south, and west is always going to be 0, 1, 1, 0, 0, negative 1, and negative 1, 0, because the radius of the unit circle is always 1.
Oh, that makes sense.
You get it now?
Yes.
That's pretty much it, man.
Alright.
So you're going to get it 100% final?
Too late.
Shh. Sanjay, you forgot to learn about radians. Man, I got you, dude. I'm pro at this. Alright. The unit circle consists of radians, such as pi over 6. As you can see here, pi over 6 is the same thing as 30 degrees. The whole unit circle consists of its own radians. And then there's a trick to learning this. Alright, basically they're all over 6. So it's basically all over pi over 6. So it's going to be 1 pi over 6, and then 2 pi over 6, but this is simplified to pi over 3. And you keep on using the same pattern, so it's going to be 1, 2, 3, 4, 5, 6. Alright, you understand the pattern? What would 7 be?
So 7 would be here, and then it would be 8 here,
Yup.
and then 9, and then 10, and then you skip 45, and then
Yup.
11, and then 12.
Yeah. You getting this? Alright,
Alright.
okay. Okay. So you saw that we skipped the 45s, right?
Yeah.
It's because there's another trick to remembering those. They're all pi over 4. The ones that end with the 5 degree, the pattern is pi over 4. So basically it's 1 pi over 4, and then 2 pi over 4.
Which is pi over 2.
Yup.
Okay.
And then 3 pi over 4,
Okay.
4 pi over 4,
Which is pi.
5 pi over 4,
Okay.
6 pi over 4,
Okay.
7 power 4, and 8 power 4.
Which is 2 pi.
So basically, with this trick, you always have to simplify them, and that's how you end up with these radians right here.
Okay.
Alright, so Sanjay, in a unit circle, a whole revolution is 360, which is also 2 pi. Which means you can call it an Xbox 360 or Xbox 2 pi.
Wait, but I play PS3.
Sanjay, show the sine graph.
Alright. Aaron, did I do it right?
I'm sorry. No. It looks like this.
Oh, so that means you must go through the origin and the sine graph.
Yes.
Okay. Alright, so...
Sanjay, graph cosine.
Alright, so you're not supposed to go to the origin. Let's go from here.
Sanjay, that's right.
Inspiration, triangles. Alright, let's go, Sanjay.
Alright, let me do a triangle. Let me try doing it first. Let me try first. Alright?
Come on, Sanjay. Man, you suck at triangles.
Freaking try hard.
My grandma do those.
Triangles. Yeah. Sanjay, can you please help explain what a 45-45 triangle is?
Alright, so we know that there's two 45 degree angles, one over here, one over here, and 90 degrees, because that would add up to 180. So we know that there's x, and x radical 2.
Also, it would be like evil mac, radical 2.
Yup. You can use anything you want. You can use a smiley face. You can use it.
Evil Holmes.
You can use evil home.
Oh.
You can use evil mac.
Alright, can you help me solve one?
Alright, so pretend we have 5 radical 2 as a hypotenuse, and
Yeah.
we know two angles are 45 degrees and 45 degrees.
Yeah.
So which means that 5 is the first number, and then
Also, that represents evil mac.
yeah, evil mac.
Also, that means that these would be the same, so this would be 5 and 5.
Yes, sir.
We completed a 45-45 triangle. Sanjay, it looks like you know all special right triangles. Can you please explain the 30-60-90 triangle?
Alright. So 30, 60, 90 is the same thing as 45. Well, it's not the same, but it's the same concept.
It's similar, yeah.
Similar. Alright. So we have a 30 degree angle, 60 degree, and a 90 degree angle.
Because it's 30-60-90, yeah.
Okay.
Oh,
So
yeah,
30 degrees points to the smallest side, because 30 is the smallest angle in the triangle.
Yeah, so that could be represented by evil Holmes, right?
Evil home, yes.
Alright.
And then 60 degrees points to the second biggest side,
Yes.
which is the
Evil Holmes radical 3.
yeah.
Oh, I'm getting this.
And then 90 degrees points to the hypotenuse, which is the biggest side, which means
2 evil Holmes.
yes, sir.
Can you please show me an example, though?
All right.
Alright, Sanjay, teach me everything you know.
All right. So we have an example. 30 degrees is one angle, 90 degrees is the other angle. So what would this equal?
That would be 60,
That would
because
be-
it's a 30-60-90 triangle.
Okay.
Ooh.
So we have one side given, which is 4. So look at this figure, and you can figure it out. It's pretty easy.
So, 4 is represented by evil Holmes, so it would be 4 radical 3,
Yes.
and then 2 times 4, which is 8.
Yes.
We completed a 30-60-90 triangle. Yeah. Aaron, you're the best at math. Can you please teach me the law of cosines?
Alright. Which means basically, this thing, it only works like with triangles. It does not have this little box thing.
A 90-degree angle.
Sure, why not? Yeah, sure.
Okay,
Right, yeah. And then the law of this is this. A squared equals b squared plus c squared minus 2ac cosine a. This is a bunch of poop. Look at this. It's too long.
Oh, I get you, man. Evil.
Oh, and also, if you could like, but change the equation, what's to find a? So it means, what means like that, it should be this. It'd be b squared plus c squared minus a squared over 2ac, all this. And that is basically your a or your angle.
I got a question. Why is there lowercase letters and uppercase letters?
Right, well, a, B, and C are all your sides. And then like your big ones, A, big, B,
Uppercase.
yeah, whatever. And then like big C are all your angles.
So you could, with the law of cosine, you could either find a side or an angle.
Yes.
Yes.
Yeah.
Whatever like you wish.
Wait, so what was it? Was it side angle? A.
Oh, not.
SS?
It's basic. Alright, it's side, or side, angle, side. These.
What about
whoa.
angle side?
Ass? There's no ass in that. You can't cuss in that.
Relax.
I'm sorry.
Relax.
I'm sorry. Oh my gosh, I have a filthy mouth. All right, please proceed.
We're done.
Yeah. Aaron, since there's a law of cosine, is there also a law of sines?
Yes. Unfortunately, yes. Alright, so
Okay.
yeah, like the law of cosine, like the law of sine, it does not work on a right triangle. It just works on like on those weird triangles. Like say like this is 69, this is 70, and it was something like this.
41.
Yeah, it's gonna be 41. And then the law, but of sine is basically A over sine A equals B over sine B equals C over sin C.
Wait, so the whole thing is a formula?
Well, yes. Well, basically, all right. For example, let's say this is 69, this is 70, this is like 2.
Okay.
Yeah.
And you want to find like this side.
Okay.
It's basically something's like basically it'd be 2 over 70. My bad. Like sine 70 over C over sin 69.
Oh, so you're giving two angles and you're giving a side and you're gonna find the other side, right?
Yeah.
Okay.
So it means basically side angle or angle side angle.
Cool.
This has been brought to you by
Evil Mac.
Productions.